Today we will discuss about group. To form a group, we need two things, a non-empty set and an operation. An operation like addition, multiplication and many more. Now, what is the definition of group? A non-empty set G is said to form a group with respect to an operation star if the following properties will satisfy. There are four properties. If a non-empty set with respect to an operation star will satisfy these four properties, then we will call that particular non-empty set with respect to that operation star a group. Now, what are these four properties? First property is closure property. What is closure property? A star B belonging to G for all AB belonging to G. I am taking the non-empty set Z. Z means the set of integer, and I am taking the operation star. If I will take any two integer, suppose I am taking 2 and 5, and I will apply this binary operation. Here the binary operation is plus. So if I will apply this plus, so I will get 7, which is also an binary operation, which is also an integer. So if I will add any two integer, so I will get again an integer. This is the closure property. If I will take any two elements from G, I will take another element from G for all AB belonging to G. A star B belonging to G for all AB belonging to G. Now the next property is associative property. A star B star C equals to A star B star C for all ABC belonging to G. Suppose I am taking three elements. I am taking three elements from Z, the set of integer 2, 3, 5. If I will add this 3 and 5 first, so I will get 8, and I want to add this 2 with the result of the addition 3 and 5, I will get 10. Again, if I will add 2 and 3 first, then I will add 5 with the result of addition of this 2, I will get 2 plus 3, 5 plus 5, 10. See, these two things are same, means 2 plus 3 plus 5 equals to 2 plus 3 plus 5. This is basically the associative property. A star B star C equals to A star B star C for all ABC belonging to G. Now the next property is existence of identity. There exists an element E in G such that E star A equals to A star E equals to A for all A belonging to G. Here this particular element E will be called identity element. In the case of set of integer, there exists an element 0. If I will add any integer with this 0, I will get that particular integer, like this 7 plus 0. If I will add this 0 with any integer, I will get that particular integer. If I will take 11 plus 0, I will get that particular integer. 11 plus 0 equals to 11 equals to 0 plus 11. So, in the case of set of integer, there exists a particular element that is 0. And if I will add any integer with that particular 0, I will get that particular integer. So this element, this 0 here will be called identity element. So in this non-empty set G, there exists an element E. That particular E will be called identity element. There exists an element E in G such that E star A equals to A star E equals to A. So this is existence of identity. Now the next property is existence of inverse. For each element A in G, there exists an element A dash in G such that A star A dash equals to A dash star A equals to E. Means for any integer, suppose I am taking an integer 7. For any integer, I will get another integer. In this case, the another integer will be -7. If I will add this 2, I will get always the identity element. Means here the identity element is 0. 7 plus -7 equals to 0. For any integer, there exists another integer, so that the if I will apply the operation over these two elements, I will get the identity element. Suppose I am taking an integer 11, so I will get -11, so that if I will add this 2, I will get the identity element. Similarly, if I will take -2, I will get 2, so that the addition of this 2 will be 0. And what is 0? 0 is the identity element in the case of set of integers z, if the operation is plus. So this is the existence of inverse. For each element A in G, there exists an element A dash in G such that A star A dash equals to A dash star A equals to E. So these four properties, first one is closure property, next one is associative property, third one existence of identity, existence of inverse. If a non-empty set G with respect to an operation star will satisfy these four properties, then that particular non-empty set G with respect to that particular operation star will be called a group, and this group will be denoted by G star. If I will take the non-empty set G and the operation star, so this is the group. Example, here I took the non-empty set Z, means the set of integer and operation plus. So here the group is Z plus. Like this, there are many more examples like Q plus. Q means the set of rational number with respect to the operation plus. Again here R star plus. Now R means the set of real numbers. R star means if I will take R minus singleton 0. If I will omit this 0 from the set of real number, so it will be R star. So if I will take this non-empty set R star and I will take the operation dot means multiplication, so this will form a group. So this is the basic concept of group.